All right, chemistry, this is part 2 of your 2-part video lecture for Chapter 8, Section 1, Describing Chemical Reactions. Now we're going to start talking about the significance of a chemical equation. Some of the quantitative information revealed by a chemical equation includes the coefficients of a chemical reaction in that they do not indicate absolute amounts of the reactants and products. Okay? That means we're not telling you how much is actually there. What those coefficients are telling you are the relative amounts, the ratios at which they need to occur. Okay? The chemicals need to be present in this ratio in order for the reaction to occur as written. So if we have or bring this equation right here, this balanced equation, this is representing 1 molecule of hydrogen for 1 molecule of chlorine. Okay, they're both in the gas phase. They're diatomic molecules, so it's H2 plus Cl2, reacting to yield another gas, HCl, but 2 molecules of this substance. This ratio of 1 to 1 to 2 indicates the smallest possible relative amounts for the reaction to occur. If you don't have at least 1 molecule of hydrogen and at least 1 molecule of chlorine, you cannot carry out this reaction. Also, you can't generate any less HCl than 2. You cannot carry out this reaction and only produce 1 molecule. Number 2, the relative masses of the reactants and products of a chemical reaction can be determined by the reaction's coefficients. Okay, again, these are relative amounts. So if we're going to use these coefficients, we can use them to figure out the exact mass present. Well, it's going to take a little bit of converting, but we can do that by now. We just use the molar mass of that substance. So an amount of an element or compound in moles can be converted to a mass in grams by multiplying by the appropriate molar mass. You guys have seen this conversion before. This should be second nature to you. If it's not, you better change that. But we're converting 1 mole of hydrogen into grams of hydrogen using the molar mass of hydrogen. Now here's where not being aware of the diatomic molecules can really hurt you. Because if I have 1 mole of hydrogen gas, that's H2, meaning a mole of hydrogen gas isn't 1.01 grams. Like if we were just to look up the mole mass of hydrogen, it's 2.02 grams because it's diatomic. There are 2 hydrogen atoms present. And so we set up our conversion factor, making sure that we have the appropriate units first. Then we can fill in the values, realizing that the units will show us where to cancel, where to multiply, where to divide. So when we interpret this chemical reaction, again, we're using the symbols, the plus mark, the reaction arrow here. This is a reversible reaction. We can bring together hydrogen gas and chlorine gas to create HCl. We can also decompose this HCl and create hydrogen gas and chlorine gas again. This is a reversible reaction. But notice the relative amounts. I have 1 mole of H2 and 1 mole of chlorine. Because these are such different size and mass atoms, 1 mole of hydrogen is only a little bit over 2 grams of hydrogen. 1 mole of chlorine gas is almost 71 grams of chlorine. And so the same amount of different chemicals can have vastly different masses. So make sure you're checking that out. Now we can double check if we add these 2 values together, the grams of hydrogen and the grams of chlorine. We add those up, and then we add up the individual masses of the HCl and the HCl. There are 2 of them. We get the exact same amount, 72.92 grams. That's the total mass present before and after the reaction. The law of conservation of mass has been satisfied. Thirdly, the reverse reaction of a chemical equation has the same relative amounts of the substances as the forward reaction. That's why we use that forward and backward arrow instead of just writing a completely separate reaction. This equation gives no indication of whether a reaction will actually occur. So when you see that forward and backward arrow, we don't know if this is actually going to happen. We're going to need to know a little bit about energetics and reaction rates, which is later on in the book. And the chemical equation also gives no information about the speed at which the reactions occur. Again, there's a completely different unit dedicated to reaction rates, spontaneity, and rates of reaction. And equations do not give any information about how the bonding between atoms or ions changes during the reaction. It simply indicates that it is changing, right? No information about how it's happening. And we'll finish up with balancing. The following procedure demonstrates how to master balancing equations by inspection. Again, you're just looking at them and using some guess and check arithmetic. First step, identify the names and the reactants of the products and write a word equation. Okay, so we have water degrading into hydrogen and oxygen. Next step, I'm going to write a formula equation by substituting the correct formulas for the names of the reactants and products. Now, I know water is H2O, but what I may not know is that hydrogen and oxygen are both diatomic molecules. So when I go to write those formulas, I need to make darn sure that I remember hydrogen is H2 and oxygen is O2. Again, I'm not balanced yet, but I'm just getting started. Next, I'm going to start balancing. I'm going to balance the formula equation according to the law of conservation of mass. Again, the law of conservation of mass must be satisfied in every single equation or something is off. That means I'm going to start by balancing the different types of atoms one at a time. And again, I emphasize one at a time. This might seem silly, but students really struggle when they try to see the entire answer at once. You have to go step by step. It is not something that you can do all in your head at once. So be prepared to use scratch paper. First, balance the atoms of the elements that are combined and that appear only once on each side of the equation. Next, balance the polyatomic ions that appear on both sides of the equation as single units. Lastly, balance hydrogen and oxygen atoms after atoms of all other elements have been balanced. So do your hydrogen and your oxygens last. Thirdly, we're continuing balancing in order to satisfy the law of conservation of mass. Balance oxygen atoms, okay, by increasing the number of H2O on the left side of the periodic table. Because I'm looking at this equation and I see that on the left side, on the reactant side, the water side, there's only one oxygen, it's H2O, one oxygen. But on the product side, it's O2. It's an oxygen molecule, and I need I need two oxygen atoms to make one oxygen molecule. So I'm going to balance oxygen first. Then I'm going to balance the hydrogen atoms by placing the coefficient 2 in front of the hydrogen. And so my final balanced product is 2 H2O reacts to yield 2 H2s and 1 O2. Next, count the atoms to be sure that the equation is balanced. Check your answer. You guys have time after your quizzes, after your tests, to check your answers. Use it. So I can add those up. I can double check. And if the coefficients do not represent the smallest possible whole number ratio of reactants and products, divide the coefficients by their greatest common factor. This will allow you to obtain that smallest possible whole number coefficient.
Balancing a chemical equation is an important technique to help you understand the chemical reaction thoroughly. The first step is to identify the reactants and products. In this example, the reactants are aluminum carbide and water. The products are aluminum hydroxide and methane. Next, write a word equation showing the change of reactants to products. Remember to specify if your reagents and reactants are solid, liquid, or gas. Now, convert the word equation to a chemical equation with chemical formulas. Now balance atoms one reaction at a time by matching the coefficient times the subscript on the left side of the reaction to the coefficient times the subscript on the right side of the equation for each element. Start with elements that are only in one reactant or product. In this example, the 4 aluminums in one molecule of aluminum carbide lead to 4 molecules of aluminum hydroxide. The 3 carbon atoms in one molecule of aluminum carbide on the reactant side lead to 3 carbon atoms in the molecules of methane on the product side. Next, the 12 atoms of oxygen in 4 molecules of aluminum hydroxide on the product side cause us to make sure there are also 12 atoms of oxygen in the molecules of water on the reactant side. Looking at hydrogen, the 4 molecules of aluminum hydroxide on the product side contain 12 atoms of hydrogen, and the 3 molecules of methane contain 12 atoms of hydrogen. This gives us a total of 24 atoms of hydrogen on the product side. This is the same number of atoms of hydrogen as found in 12 molecules of water on the reactant side, so our equation is balanced. We double-check to make sure the coefficients have been reduced to the smallest number possible. In cases where you have polyatomic ions, you can balance the ions as whole units if they appear on both sides of the equation. Always be sure to make sure the charges balance.
Alright, let's finish up with some sample problems. The reaction of zinc with aqueous hydrochloric acid produces a solution of zinc chloride and hydrogen gas. Write a balanced chemical equation for the reaction. So I'm going to start by writing the word equation like we've done already before. I'm going to have zinc and hydrochloric acid. I'm going to, on the product side, put zinc chloride and hydrogen. Now I'm going to transfer all of those things, all of those names into formulas, and I'm going to insert the states of phase. So now I have zinc solid, HCl aqueous, reacts to yield, zinc chloride aqueous, and then hydrogen gas. But I'm not balanced yet, but then again, I'm not done. Lastly, I'm going to adjust the coefficients. I'm going to balance chlorine first because it's combined on both sides of the equation. It's combined, meaning it's bonded to something. And then I'm going to check the atoms. I'm going to count the atoms to check the balance. And when I add all of these up, I find that I have the same number of zincs on each side, I have the same number of hydrogens on each side, and I have the same number of chlorines on each side. And that means that the law of conservation of mass has been satisfied, and this is a successfully balanced chemical equation. All right, chemistry, that's going to do it for this video lecture. I will see you next period.